So this is a functions question. They give you a function and we're probably going to be doing a little bit of calculus with it. We're asked to find the altitude, where we're told that h is the altitude and the altitude at which the pilot must begin the maneuver. So the whole idea about time, okay, time is t is in seconds after the maneuver begins. So the key thing here is understand that your maneuver begins when t equals 0. So if we substitute 0 into this formula, what do we get? So working through that as a formula shouldn't take too long to realise the answer is 200. The units are meters, so we make sure to put units in, otherwise we lose a mark. In part B, we're asked to differentiate h. So dh by dt is taking the h function and differentiating it. So in that case, what we do is we take the power and multiply it by the coefficient for each term. So it's 3 times by a third, 2 times by minus 15 over 2. And you go through the process of differentiation, standard by rule. So dh by dt is going to be, well, 3 times by a third is 1, and reduce the power by 1 becomes t squared. Then we have 2 times by minus 15 over 2 gives me minus 15, and reduce the power by 1. The basics of the x term, as we call it, but here it's the t term, just becomes a number, and the constant on the end disappears. So we're left with 1t squared minus 15t plus 50, and we don't necessarily need to write the 1 in there. We're then asked to use our answer from part 1 to be able to find the time it takes the stunt plane to reach the top of its initial climb. So basically when the height gets to the maximum value, the local maximum, before it begins to dive again. So to do this, the key thing we're interested in is when is the first derivative function equal to 0. So when is t squared minus 15t plus 50, when is that equal to 0? Well, going through the process of factorizing, which I'm not going to go through step by step, but the key idea is t minus 10, t minus 5 are the two factors. So the two roots for that quadratic are 10 and 5. So the first time there's a sort of a maximum is when t equals 5. The key idea here is we have the initial cubic equation that we're given right at the beginning is a positive cubic equation. We've basically got that sort of type of curve. The first turning point is the maximum and the second turning point is the minimum. So our max is at 5 and 10 is the minimum. We're not interested in that in this particular moment. So the answer is t equals 5 and the units of measurement is seconds. So make sure you put that in there. And the altitude at that moment in time is when t equals 5, what is my height? So going back into the very original function, we're just going to work out what h of 5 is. And that works out as 1825 over 6, which is 304.16 recurring, which simplifies to 304.2 meters to 1 decimal place. Make sure you round your answers to as required, the correct, and also make sure you put your units in there as well. Moving on to part C, it talks about the rate of climb. Now, to some extent, this was straightforward if you realise what they were referring to when they talk about rate of climb. The rate of climb is how sort of fast your height changes. So what is the change in height as time goes on? Now, if you think of the change in height, if you think of the ideas that would have been discussed in differentiation, your change of height with respect to time is dh by dt. So that first derivative is your rate of change, and we want this for when t equals 3. So if you remember from the previous page, we had a formula of t squared minus 15t plus 50, and we want this for when t is 3. So 3 squared minus 15 lots of 3 plus 50, which gives me an answer of 14, and it's a rate of change, so it's speed meters per second. 14 meters per second. For part 2, they give a long spiel story, and they basically end up with mentioning that dH by dt is 20. What they're suggesting is, at what point in time is dH by dt equal to 20? Just see what's going on at that moment in time. So we're after t squared minus 15t plus 50 equaling 20, which gives us t squared minus 15t plus 30 equals 0. Since they tell us that they want the answer to correct the nearest meter, it's likely we're going to need to use the minus b formula. And if we use the minus b formula, to cut a long story short, and to be honest with you, the space they've given you here isn't particularly enough, we get two solutions, and those two solutions are 15 plus or minus the square root of 105, all divided by 2. And when you work those two answers, you end up with 12.62 meters and seconds and 2.37 seconds. Now again, thinking about what's going on, this flight is this idea, this positive cubic equation. At a certain point, it's quite steep, and it also gets quite steep later on. But there's a moment in time where the slope of that line, the rate of change is 20. So the idea is this plane is coming in and joining whatever route that's going on, coming in at that point in time, and that first happens at 2.37 seconds. Okay, the later moment in time when it would be happening would be again when the slope is 20, and that would be at 12.62 seconds. So the answer to the question is, when can they start joining the maneuver? It's 2.37 seconds. Moving on to part D. They tell you that the greatest downward speed occurs when acceleration is 0. Now, to some extent, one of the things you need to know and learn about is the idea of when you have a function that represents distance. So this h is the distance, and then you've got your speed or velocity, and you've got acceleration. And these three ideas, you need to understand there's a connection between them. So the basic function is your distance, your height. Your speed then is going to be the derivative of that, your first derivative, okay, which would be known as h dashed, or it will be represented by dh by dt. And your acceleration would be h double dash, the second derivative, or we say d2h by dt squared. So there's a relationship. If you differentiate your distance function formula, you get speed. If you differentiate that, you get acceleration. And so that's why they're asking us to work out d2h by dt squared, because that is going to be your acceleration. And they're telling you you're going to be looking at when the acceleration is equal to 0. Let's go through finding the second derivative first. And all it involves us doing is taking the first derivative, which was, if you remember, t squared minus 15t plus 50, and all I need to do there is differentiate it. So d2h by dt squared is going to be, now again, take the power, multiply by the coefficient, and reduce the power by 1. Take any sort of quote x term and make it a number, and any constant number disappears. So we have 2t minus 15 is the second derivative. Then it's asking for t when the acceleration is 0. So all we want to do is say to ourselves d2h by dt squared is 0. When is that 0? When 2t minus 15 is equal to 0. and it doesn't take long to work out that we have a time of 7.5 seconds. And the greatest downward speed of the stunt plane occurs at that moment in time. So when t is equal to 7.5, what is going on with the speed? Well, don't forget the speed is this expression dh by dt, your rate of change in your sort of altitude, your rate of climb. And so if we put that 7.5 into the formula, so 7.5 squared minus 15 lots of 7.5 and add on 50, we get an answer of 6.25 meters per second. Now that's a downward speed. Those of you who might do physics would appreciate the idea of vectors. Having so one direction is positive and the other direction is negative. So you might appreciate that this is a negative speed, a speed going downwards. So sometimes it's worth mentioning that, but generally speaking, they're telling you it's downward speed. So 6.25. Some purists might think you should be saying minus 6.25.